Hi, I'm Bruce Kyle. I'm an architect evangelist at Microsoft. I work with software companies in the Pacific Northwest. I'd like to introduce Stuart Solarier. Stuart is a software architect with CheckFree and a Microsoft Most Valuable Professional.
Hello, I'm Stuart Solarier, and I blog at visualstuart.net. I'm a Microsoft MVP on connected systems, and until now, most of us have been programming in C# 1.0. From that .NET 1.1 era, and even if we've got a newer version of the language, we're still using it as if it were C# 1.0. We're going to take a look at what's new since 2003. What changes the way we program? I'm going to focus on the language, not practices, not applicability, not even usefulness. So opportunity for abuse abounds. We're going to do just enough to be dangerous.
Hey, Stuart. What's today's Whirlwind?
We're diving into C# 2.0 that released on the .NET 2.0 framework, and today's topic is generics. Generics are parameterized types. If you're familiar with C# templates, they look an awful lot like templates, and let's just take a look at what that syntax would be. So here's a class called pair, and I'm saying that I've got some metastatic variables, in this case s and t, that are going to specify types, which I'm going to specify later, not while I'm writing this class. So here I've got two members of that class, first and second, and first has type S and second has type T, those types that I declared up at the top of the class inside of the angle brackets. And I've got a constructor for pair. And why would I possibly want to do something like this? Well, hey, I get into those places where I want to return not one but two values from a method, and I could use pair as a way of collecting two arbitrary typed values up, preserving their strong typeness. And so here's an example where foo is a method that returns a pair, and that pair is made up of a bool and an int. And I'm going to do that by returning. I'm going to new up a pair, tell the compiler what two types, those metastatic variables that we referred to before, s and t. S is bool, t is int. So I need to construct it with, let's see, a bool and an int. So I'm going to use true and 17, and use that pair of values as my return value from foo. Now, this is not C++ templates. I just say that in case you've had experience there. They're not quite as powerful as the C++ templates were, but they're great for containers. And so as an example, let's take a look at collections that we had before we had generics. So this is from the .NET 1.0.1.1 world, where the collections that I had are collection of type system.object. So I have a stack of objects here that I'm newing up, and I can push a 7 onto them. And when I pop that 7 off, I'm really getting an object, and I have to cast it back into an int to be able to do something with it. So that's why I've shown the cast there in red. With the system collections generic, now I have a stack of some type t, and I'm specifying in this use that I want to have a stack of ints. And so you can see the syntax there. I use the angle brackets around the types that I'm specifying for this generic. And now when I push 7 on the stack and then pop it off, it knows that this is a stack of int, so there is no cast involved. So that's a little bit nicer syntactically, but there's more going on. Now, this is actually supported not just in the language, but in the IL and CLR. So generics are a feature that any managed language can take advantage of. There are two main benefits for having generics, so far as I see it. First one is type safety. With my old non-generic collections, where I just have a stack of, well, objects, that means I could push an integer on and then push a string on. Now, what would that mean? I don't know. And when I pop some object off, what type am I expecting that object to be? Now what, after I've popped it off? Go into some big ugly switch statement that I have to maintain of the types of things that might be on there? I don't know. Kind of looks ugly to me. With generics, I say I've got a stack of ints. And when I push 7 on, all is fine. If I try to push a string on, I get a compile time error. Compile time errors are the best kind of errors because it means you cannot even run before you fix this error. So I always like compiler errors. The second benefit that we get is performance. So value types, we're talking about things that I define with struct, some of those built-in types like int. They require boxing and unboxing if I'm going to be treating them as objects, and I've got collections of objects. So that value type needs to get boxed into being an object and unboxed from an object back to a value type. So here's an example from the code that we were looking at before. In the background, I've just sort of cut in there what I would see in ILDASM for the disassembled code generated by the C# compiler. And I see when I pushed that 7 on the stack, that had to generate some IL saying box 7 up into an object. And when I pop it off and cast it, I'm going to have to unbox that. So that's extra work that needs to get done just because I'm putting value types into that collection of objects. By contrast, here's my stack of ints. And there is no boxing or unboxing required. It really is a stack of ints. Why is that important? Well, boxing increases pressure on the managed heap, and that means garbage collection has to happen more often. Similarly, even if I'm not using value types, if I'm pushing reference types on the stack, that downcast that I have to perform to convert that from an object back into my class type also requires some extra processing. We don't have to do any of that with generics because it's strongly typed all the way through. So that's generics in a nutshell.
Hey, thanks, Stuart. For more information for software developers, see the US ISV Developer Evangelist blog on MSDN.
Hey, it's been fun. Again, I'm Stuart Solarier, and I blog at visualstuart.net. See you next time.